Hello, hello, welcome.
Hi, everyone. Thanks for coming. Oh, it's been a long day, huh? It's been a long 3 days. And I know Steren and myself really appreciate all of you sticking around and coming to our session. So just one more time, thank you, everyone.
It's good to have you with us. This is Myles Borins. Myles is a developer advocate on Google Cloud. We've been working together for the last year. He also happens to be the director of the Node.js Technical Steering Committee. And of course, he's a long-time Node.js lover. I think the first time you used Node.js was for an art installation, something like that? Nice.
So this is Steren. Steren is a product manager for Google Cloud Platform on the serverless team, and we've been working really closely on new Node.js technologies. Previously was involved in the Stackdriver error reporting product, and you used Node in production in 2011? Was that like 04 or 06?
06, I think.
06. Did anyone start with Node 06 in the audience? Right on. That was buggy. I think that's like right when they introduced util. But fun fact about Steren, his wedding invitation was actually written in JavaScript, and it's still online. And that means your wedding invitation will never break.
Never. The web. All right. So who can name this French pastry? So it's called a millefeuille, literally translating to 1,000 layers. So it's basically a cake made of many, many, many layers. So one of my teachers used to say, in French, tout problème est un millefeuille de choses simples. So translating, every problem is a millefeuille of simple things. So you should understand every problem can be broken down into many simple things. And I think this is also true for software, for code, but also for software architectures. If you break down your big app into simple things, it will be simpler. You break them down into microservices. So that brings us to microservices. Why microservices? Well, maybe your app has grown too big. Maybe it is actually hard to understand, develop, maintain, manage. This is why microservices can be a solution. You break up the monolith. You decouple those microservices. You make them simpler to understand and maintain. And potentially, each service will be written in a different language, owned by a different team, and deployed independently. As a consequence, they will scale independently. If you decouple them, the scaling is independent too. And by making them more fine-grained, that will result in a better utilization of your resources. That will result in a lower bill for you. And lastly, microservices pair great with Node.js due to the asynchronous nature of Node.js. So microservices break up the monolith, scale independently, and pair great with Node.js. But what is Node.js?
So I was given this slide. Node.js. JavaScript. How many people like JavaScript? Sweet. So I don't know if any of you have seen this little emoji thing before, the rocket turtle. That was the Node.js logo. It was kind of like a joke. Substack drew this turtle on a rocket ship because JavaScript was not supposed to be a fast language. And it was like pretty amazing how fast, both as a runtime, but also for iteration. Like Node is one of those things that just, you have an idea and you can get it done in like 10 or 15 minutes because someone's already written the module. You just need to find it. But so at its base, Node is a JavaScript runtime. We take the V8 virtual machine that comes in the Chrome browser. We wrap it with libuv, which is an underlying architecture wrapping all the system calls, and that kind of abstracts all the different platforms and allows developers to just write JavaScript and be able to do compute, write servers, and all those different things. It allows you to leverage your front-end skills. It's event-driven. What that means is that compute is driven by events. Something computes when something happens. That can be an HTTP request. That can be some sort of message coming over a socket. It can be user input with a keyboard. It can be some sensor if you're working with IoT. Any form of I/O. So anytime there's input, some sort of compute runs. The event-driven architecture plays really great with async non-blocking I/O. Multiple things can run in parallel without blocking each other. When I make some sort of request over a socket, I'm able to suspend, let other things execute, and resume when I'm done without requiring the developer to program any of this. It just happens. Many events execute without blocking each other, and this ends up being really great for web servers because it means multiple people can connect to the same process at the same time, and it just works. You don't have to worry about mutex. You don't have to worry about timing. You just worry about handling the events. So to sum that up, Node.js is a JavaScript runtime that's event-driven with async non-blocking I/O.
And the last term that we need to define from the title of this talk is serverless. So who here is using a serverless product? So we should agree that there are a lot of definitions for serverless. I'm going to highlight here the key characteristics that we will use along this talk. The first one, that to me is the main characteristic, is that you pay for what you use. So it's a billing model. If you don't use it, you don't pay, and then the bill is proportional to your usage. Of course, you don't need to provision in advance any resource. All of this is done on demand. So why are we able to achieve that billing model? Because of an operational model. So a serverless product will scale with usage without having to worry about it. It grows with you from a single developer to a company with thousands of developers. It follows your usage. And why can it scale? Well, because of a programming model. The cloud providers takes care of the rest. You focus on your code. That means that no infrastructure management, no VM management, everything is abstracted from you. So you focus on your code. That also means that you focus on delivering business value and value to your users. So to recap, serverless, pay for what you use, it scales, and allows you to focus on code. These are the principles we are going to use along that talk. And you will see it's not only for compute.
So Google Cloud has a number of different serverless offerings. We have Cloud Functions. How many people here have been using Node and Cloud Functions so far? Cool. We've got App Engine Standard. We've got Data Store, Cloud Storage, BigQuery PubSub, Dataflow, ML Engine, the Firebase suite, as well as app scripts. And all of these different products, what defines them as serverless and makes them all serverless is the fact that you don't have to manage them. We will scale them for you. We'll manage them for you. You can utilize them as much as you need it.
And today, we are very proud to share with you the preview of Node.js on the App Engine Standard environment. Thank you. So yes, we are adding a new language to App Engine Standard, Node.js. We will release it in a few weeks. So let's see a small demo of Node.js on App Engine Standard. Myles is going to tell you more about it.
So this package.json file is outlining a Hello World application. We have a single start script that calls Node on server.js, which, fun little fact, if you don't define the start script and you just run npm start, that's actually the default command it will just do, which can be really confusing if you're not expecting it to do that. And it has a single dependency, which is Express. Here's our Express app. we're making an app using Express. We have a single route, and we celebrate Node.js on App Engine Standard. We listen on an environment variable for the port, or fall back to 8080 for local development. And there's one more thing that we'll need to get this onto App Engine Standard. It's just a tiny bit of YAML. This one line of YAML, runtime Node.js 8, is the only extra thing that you need to add to the majority of Node.js apps. And it will work as soon as you run a single command. And that command is gcloud app deploy. So Steren has something loaded up on his computer. So we're going to switch over to it right now. And you're going to see Steren's in the Cloud Shell. He's got that app that we were just showing you. And he's going to type in that command that I just mentioned, gcloud app deploy. So this is how you know it's a real demo. But we haven't actually deployed yet. We're ready to deploy now.
Ready to go?
You ready?
Let's do it.
So we're starting to deploy, and in the time it takes to deploy, I'm going to try to list all the things I like about it. So it's an idiomatic Node runtime environment. So that means we're using the exact version of Node that gets published by Node.js. There's no special runtimes. There are no special APIs. It's the same app you can run in other places. It scales to 0. So when you're not using it, you're not paying for it. It's a managed runtime. So that means everything but your code and the Node modules that you're using will get updated by us. If there's a security fix that needs to land into Node or OpenSSL, and trust me, there are, we're going to patch that for you without you or your users really ever noticing. Oh, wow,
like
I couldn't even get to it. It's already deployed. You also get npm install in the cloud, so that also did npm install. You get hybrid monitoring for free and free HTTPS. Wow, that was fast.
Right,
and we can go and we can see the service right now is already running.
Oh, sorry.
The bar was hiding it. So there you go. This service has been deployed. We're already running it. And this is, in my opinion, it's a really great user experience, being able to deploy, have it up in the cloud so quickly, and be able to share that with people to take a look. Okay. So now that we're done with the demo, we're going to talk a little bit more.
So this was Node.js on App Engine Standard environment. It is idiomatic, which means that you can use any module from the npm registry that you want. There is no API or language restriction. As you've seen, it deploys fast and scales instantly. And as Myles said, it is secure. So you get one-click HTTPS for your custom domains, and it auto-updates. So I will now do a deep dive into 3 updated pieces of our infrastructure. The first one is what we call internally faster than light builds. So what's that? When you type gcloud app deploy, we will first only upload the files that have actually changed since last time. OK, this is an optimization for the upload process. The faster than light build arrives after. So what we do is we look at your package.json and package.lock.json to install your dependencies in the cloud. So we do npm install for you in the cloud. Good. But actually, so this is what we defined as the speed of light. But actually, if we notice that your package.json and your dependencies haven't changed, well, what we are going to do is just give you what we just gave you before if you do a new deployment. So we use our caching system to give you the cached modules, and that's how we can go faster than light. This was the first piece of updated infrastructure for this new runtime. The second one is a new runtime environment. So let's see a little bit of the technical stack. So first, you gave us your code when you did gcloud app deploy. So this is your application code. As I said, we installed the Node modules for you, so including the native modules. They can be any modules. Good. Under that, of course, there is Node.js. And here, this is an off-the-shelf Node.js. There's no special customization here. Node is relying on the OS packages. And for example, you might have heard about headless Chrome. And yes, all of the packages needed to run headless Chrome are present in the App Engine image. And that lives on top of a regular OS, which is Ubuntu. The last three pieces, Node, OS packages, and Ubuntu, are automatically updated without you having to worry about it. So we will automatically update your Node.js version, the minor and patch version of the Node.js. The OS package and the OS is also automatically updated. All of that lives in a secured sandbox. And this is a new sandbox technology that we are introducing with this new runtime. Under the hood, the sandbox is based on gvisor. So gvisor is a container runtime sandbox that we open sourced last week. Check it out. This is our new runtime environment. And the last piece of infrastructure I would like to highlight is automatic scaling. So what is automatic scaling? Let's take an example. So App Engine constantly monitors the instance capacity and traffic, your application capacity and traffic. And it ensures that the appropriate number of instances are available to run your application. So what does that mean? Let's take an example. So as I said, if there is no request arriving to your application, there is no instance scheduled. And when I say instance, it's not a VM instance. It's an abstract that we name instance. OK, now some traffic arrives to your application. Well, we will scale up as fast as possible one instance. Here, I'm going to pause for a second. I want to highlight one concept that is very important for developers. The very first of these requests will hit what we call a cold start. That means that this request will actually hit the instance while it is starting up. And this usually results in a higher latency than usual. Of course, we try to, not we try, but we do boot up the instance very, very fast. But you also have a responsibility here. You have to ensure that your start command is fast too. So in the start script of your package.json, make sure to not do things like build or a lot of initialization. Do the minimum required to start your application, because this will have an impact on the cold start of your application. OK, so here, as I said, the very first request will hit this cold start. But the next ones, everything is fine. But then your traffic will start to increase a little bit. And here, before this first instance arrives at capacity, we will anticipate that you need a second one. And we will actually schedule a second one, so that when you actually need it, it's there. Doesn't need to scale more. And now let's imagine your app is featured on a popular blog post, and you have a huge spike of traffic. Well, don't worry. App Engine scales very fast. So we will scale up instances as much as needed. You can tell us a maximum of number of instances if that matters to you. And of course, when things go down, well, we will ramp down the number of instances to 0. So that's what we call automatic scaling. You did not have to do anything to get this behavior. But this is not new at all. App Engine has been doing that for 10 years, 10 years now. What is new is that actually we updated our automatic scaling algorithm. So the updates include, it is more predictable. As a developer, you will better understand how it behaves. When you look at your instance chart, you will better understand it. Second, it actually improves instance utilization and performance. So we measured a reduction of 30% of those cold starts. So that means that the tail latency of all of our apps across all of App Engine has went down. And also, better utilization means lower bills for everybody using App Engine. And this was released in the last months. The third point are new settings that we are introducing to better control these automatic scaling algorithms. Those new settings help you balance between cost and performance. Also, as I said, help you cap the number of instances so that you can cap your bill, but also the number of database connections, for example. So this was 3 pieces of infrastructure we updated. Up to you, Myles.
So we built a product with Node.js comprised of microservices to share with you today. And Steren's going to demo it on the machine for us right now.
All right, so go for it.
So we created a web page watcher. And we're able to put an address into the submission bar, and it will start watching it. And at 5-minute increments, it's going to use headless Chrome to take a screen capture of the website, and it's going to compare it to other screen captures. And it's going to only take screen captures when there's actually been a difference in the page. This website allows you to set any number of different websites to watch. And this has been a lot of fun to use on like the Google website to see the changes to the Google header. You could use it to watch your own site to make sure that things aren't going down if you have a personal page that isn't changing a lot. But it was a way for us to experiment with breaking things into different services and put together a really great example. So Steren, did you have anything you wanted to add to that?
I want to tell you how it's done.
That sounds great.
Let's switch back to the slides. So this is our product. This is our application, a website watcher. How did we build it? Well, every 5 minutes, there is a cron job that will trigger a first microservices. This microservice is called task scheduler. The job of this microservice is to ask our database for a list of web pages to screenshot. When it receives this list, it will actually enqueue into a pub/sub topic a message for each page to screenshot. This is our first microservice. Then pub/sub will push to a second microservice the web pages. And the job of this microservice, it has one job, is to take screenshots. So as I said previously, this is using headless Chrome under the hood in order to take those screenshots. So it opens a web page, takes a screenshot, saves it into Google Cloud Storage. That's its only job. Now, a new file arrived into Cloud Storage. This will trigger an event. This will send an event that will trigger a Google Cloud function that will compare this new screenshot with the last known reference screenshot for that web page. We call it image diff because the job of that function is to compare 2 images, and if there is a difference between the images, it will store the new image into a new folder in Google Cloud Storage. So this is how we continuously get the updates of all of the web pages that we want to track. OK, now a user arrives onto our website. So an HTTP request arrives onto our web frontend, another microservice, that will query our database, asking for a list of web pages. You've seen that list. And when I see the detail of one of those web pages, we actually display the screenshots. So it also queries cloud storage. So that's how we've built our product. 4 custom microservices, all communicating with each other. And now Myles is going to tell you more a bit about the code.
So the first microservice that we're showing is our screenshot server. You're going to notice we're using async functions because App Engine standard comes with Node 8 out of the box. We're going to start a browser session by awaiting Puppeteer to launch. We're going to then await a new page from the browser object. We're going to await surfing to that URL. We'll await setting the viewport to the size of the image that we want to take. And then we'll await a screenshot in the image buffer. We then await closing the browser, and then we return the image buffer. We're doing a lot of asynchronous work in here. that is going to allow us to use the same service to pull lots of different images at the exact same time without blocking. We're able to do it in a single linear fashion without having to manage a whole bunch of callbacks or any sorts of promises, although under the hood, there's lots of different promises going on. Now, this is deployed using App Engine Standard. And there were some other talks going on this week about headless Chrome, and you can find those if you go and check the I/O webpage later. So this is our service, the part of the service that actually saves to a bucket. Similarly, we're using async and await to be able to do this in a linear fashion. But we go to the bucket, we rename the images to be based on a timestamp, and we save it and await that information and then log it. And because all of the Node.js client libraries support promises, you're going to be able to use our various client libraries to talk to all of our various servers using async await right out of the box. And then the last thing that we wanted to show you was the image diff from our Cloud function that's doing the image diff. Every time a new file gets added to a cloud storage bucket, this function's automatically called. And what we wanted to just show is how quickly, from the event that the function's executed with, we can grab the file and the context at which of that file inside a cloud storage. So we don't even need to write any logic to tie the two together. We just need one service to save it, and this new service just reacts. And one thing that's really great about all these different services is that out of the box, if you start logging, Stackdriver is going to grab all of those logs, and you're going to be able to use Stackdriver logging to look at all the logs of what's going on. And I don't know about you, but I never write a service right at the first time. I run it locally, and then it works differently in the cloud. Being able to just log and have it working is really awesome. And for the demo that we put together, you'll see online later, we used Bunyan and have a pretty robust logging system that you'll be able to take a look at.
So let's look at the Cloud Console to see those microservices in the console. So as I said, we do have 3 App Engine services. So you will see them on the App Engine dashboard. So opening my services. Oh, we have 4 because I just deployed one earlier with you. So default, screenshot, and task scheduler. We have one Cloud function. So if I open it, it will display here. Image diff, as you see, the trigger is a Cloud Storage bucket trigger. Now, as Myles said, out of the box, all of your logs are going to be collected into Stackdriver logging. So here, let me filter out some of those logs and only show the application logs that are here. So these are the logs of our app across all of our services. So as you see, we loaded the website. We also, what else did we do? We saved screenshots. So all of this gets logged and with a different severity. Here we had an error apparently. And the last thing I wanted to show is that when your logs go to Stackdriver, they are going to be collected and grouped together by Stackdriver error reporting. So here, what you see here is a list of error groups. So all of your errors, if they are the same, are going to be grouped together and displayed as one group. So this is out of the box when you use App Engine, especially Node.js on App Engine. That is all for the demo of the resources. Let's go back to the slides. And now I'm going to talk a little bit more about how to connect microservices. So, of course, you can directly call a service. So that's the case, for example, when a client calls our front end. So an HTTP request arrives, that's a direct call. It's also the case when you receive a webhook. When you receive a webhook, that will be a direct call. And lastly, 2 microservices can call each other directly, of course. Another kind of communication between microservices, which actually can be quite convenient and useful, is what we call asynchronous execution and events. So if you remember, every 5 minutes, one of our services was scheduled. So this is one kind of scheduled services. now you remember, anytime we put a file into cloud storage, something happened. A function was triggered. So this is another kind of communication. We call that reactive services. So when something happens, this is triggered via events. Another way to do asynchronous execution is to actually use a task queue. So one service will enqueue a task into a queue, and then this queue will make sure that the task is executed by retrying if needed and by dispatching at the rate that you want. So task queues can be quite convenient for asynchronous task execution. And lastly, as we've made in our demo, you can use a publisher and subscriber pattern, where one service will publish a message into a pub/sub topic, and one or many other services that are subscribed to that topic will receive the message. And lastly, maybe this is obvious, but sharing storage is also a way to communicate between services. You can have two services sharing the same database. That is a kind of connection. In our case, we used Cloud Data Store and Google Cloud Storage. So connecting microservices, you can directly call them. You can use asynchronous execution and events and shared storage.
So after kind of talking about all these different types of services and products, you may be wondering, like, when should I use functions, or when should I use App Engine, or maybe when should I use a Kubernetes? These decisions are things that teams need to make. So I want to dig a little bit more into functions first. So we talk about events and async, and that's a lot of the programming model that's used for this. So you have different kinds of triggers. You have pub/sub, you have Google Cloud Storage, so whenever something ends up in a bucket, it triggers it. You can have database transactions. One that's really interesting is logs. So you can have a function run every time you see things in logs. You can use that to filter certain kinds of error messages, or automate PagerDuty or something fun like that. Maybe not PagerDuty. But you can also use webhooks. Any sort of HTTP can go and call in. One of the things that's nice with Cloud Functions is they can be really single purpose. It has a well-defined programming model with a really quick way to get to the data that's coming in from the event. One that I really like is an emailer, for example. So you may have a whole bunch of different services that need to send email. So if you have one Cloud Function that just does all the auth and all the message handling to whatever email service you're running, you can make an email topic on pub/sub and just publish a to, a from, a body, and a title, and an email will just go out. And let's say you decide to change your email provider service, you just have to change that one Cloud Function, and no one else needs to refactor their code. As long as you have a defined API surface between all your services that isn't broken, you could change it to any language or any service you want to. So on the other hand, we have App Engine. App Engine, for example, HTTP services are generally what are exposed. Now, it's multi-purpose, though. You could use it for front-end applications. You can use it to serve static resources. It does not have a defined function wrapper, so you can just take any Node application for the most part that you've already been running and just launch it. If you have multiple different things that are going, multiple routes that you're handling, database queries, templating, you may find that running something on App Engine makes more sense for the use case than a Cloud Function. But you can define your own compute relationship. Cloud Functions and App Engine work really great together. If your team prefers thinking about things as functions, run with that. I know entire websites that have thousands of page views and hours, and they're written their entire infrastructure on functions. And there's tons of big Node apps that could just run on App Engine and scale as necessary. You could really break apart the problem as it makes sense to your team as you need to go, and they both share a lot of similarities. They're both going to scale to 0 when you're not using them. You're going to pay for what you use. And under the hood, they're using the same sandbox. They're using the same auto-scaling. There's no right or wrong. One of the cool things about it, too, is you can start thinking, it almost becomes more of a difference of how you want to think about your compute and how you want to factor your code. But from an ops perspective, they're very similar. And we also wanted to announce today that Node 8 is going to be coming to GCF really soon. So you're going to be able to use all of these features both on Cloud Functions as well as App Engine.
All right. To recap, deploying Node.js microservices, serverless Node.js microservices. What have we seen today? First, breaking up the monolith. So as you've seen, we've built an entire product made out of very, very simple pieces. Each of these pieces is a few files, or even one file for some of them. Break up the monolith. Microservice architectures can help you build rich products from a decoupled, small, scalable, maintainable, understandable components. Second, we showed you a preview of Node.js on App Engine standard environment. This is coming in a few weeks. And lastly, what you should remember is that Google Cloud Platform has everything you need to build serverless microservices using Node.js. And personally, I can't wait to see what you will build with Node.js on App Engine Standard and all of those products.
So,
thank you.
Thank you. So if you enjoyed the session, you can go to and get your feedback here through the schedule link. You can use web or Android or iOS. Just let us know what you think. Here are some resources. You'll find the docs for the App Engine Standard. You're going to see the functions, and the demo that we were showing you today is all there. And so just a quick round of applause for everyone who is watching at home on the live stream. And one more quick round of applause. You don't really see it, but there's some amazing people at the back of house and the back here who have been working all day tirelessly. Just a round of applause for them. And so don't go yet. Hold on.
One more thing. One more thing. Look under your seat. No, joking. Look over there. Look over there. We have a stand where you can scan your badge, and we will send you invites to try tomorrow or as soon as we get your emails, Node.js on App Engine Standard environment. So if you want to give it a try, scan your badge over there. Thank you.
Thank you.